Thank you very much for the warm introduction there. And I'm excited to be here and to talk about ag tech in the wine industry. I come from a little further south from here, originally from New Zealand. I've been a grower, vineyard manager, viticulturist all my life, right from when I left university. Always had this interest in technology, started embedding technology in vineyards that I was running down there all those years ago, about 25 years ago. And since then, I've headed regenerative farming, sustainability, large-scale conversions to organics, and here in the United States, in Europe, and New Zealand and Australia. And what I've seen in those travels across the world is when the devastating effects of conventional farming, when there is no sustainability programs, when sustainability programs are put in place, how quickly ecosystems start to restore, when you start regenerating land, how quickly impact can be made. And so when we look to the future of wine growing, I think the next phase that we're in is how do we use technology to go even further? Because we've come so far as an industry, but in order to go that next step, I think technology is going to play a massive role in that. And you see this in other industries, this macro trend of AI, robotics, automation, big data. And what does that mean for the wine industry? And so this is a practical overview from a viticulturist perspective, someone that's run large-scale sustainability programs for one of the largest wine companies in the US, and also from a perspective of someone running a technology company. I'm here with this wonderful panel of practitioners here that we'll introduce after this brief overview, and we'll dive into what they're doing on their vineyards, what they're leading, and then we'll keep this open and lively, so any questions as they come, just fire them away. Nothing's worse than having one of those burning questions and you kind of forget about it sometimes by the time you get around to being able to ask it. Okay, so these are these four big questions that we're going to address in the next 15 minutes. There's a lot to cover, but what is the state of ag tech? What problems is technology actually solving? And where does technology make the biggest difference? And then where do you start? And then how do you choose with all the different options that there are out there? So the state of ag tech in the wine industry, I mean, there's been a lot of investment. There's a lot of integration happening. Close to $3 billion has been invested in global ag tech across viticulture. A lot of wineries and vineyards, you're already using ag tech in some form, and we'll go through like a timeline of ag tech in viticulture. There's big increases in robotics, automation off a very, very small base. And then one of the biggest drivers for growers and vintners is around labor, cost of farming, water efficiency, and then also chemical use as well. So we're going to frame this up from a large picture of kind of what's going on in the agricultural space, and then I'll give you an example of how we're addressing this at Saga Robotics before we go into the individual presentations. So, history of ag tech, I was just reflecting on this and before making more changes to my deck, but before mechanical harvesting, there was the horse, and then there was a tractor. And so that was a massive revolution in ag tech when we went from horses to tractors, a huge shift in productivity in particular. Not so much from a sustainability perspective, but from an efficiency perspective. It drove the whole industrial revolution, made us super productive. This led into mechanized harvesting, a huge productivity increase. It's led further into ag tech evolving into drip irrigation, monitoring-based systems. And then the invention of GPS, GIS mapping systems that many of you would have incorporated. Then that led into remote sensing, NDVI. I started my first ag tech company down in New Zealand called Spatial Solutions, where we took NDVI sensors, mounted them on quad bikes to produce these maps of vineyard variability about 20 years ago. Then came drones, and drones are still a kind of big part of what's coming and what's already being implemented. More sensors in regards to carbon sequestration sensors, soil moisture monitoring sensors, embedding data into our decision making. And now this next wave, I think, is arguably the most exciting that we've seen in a long time. And this ladders into the macro trends that are happening in industries around the world. AI, what does that mean for us as wine growers? How can we use this in viticulture and winemaking to make better decisions? Robotics, when you think about sustainability and we're running 8 to 10,000 pound tractor and sprayer rigs spewing out diesel and carbon into the atmosphere, a tractor and spray rig can contribute close to half a ton of carbon per acre per year. So what are we gonna do about this? Robotics, electric, automation is going to help us get there to really advance sustainability and build on these prosperous ecosystems. But the agtech revolution has had its challenges. It hasn't always been super positive. There's been some challenges. There's been a mass explosion of agtech. There's been a number of bankruptcies, distresses that many of you would have been aware of. This is a very capital-intensive business. A lot of investment went in early. There's been some pain, but there's some emerging winners coming out that are providing real-world solutions to problems we face as growers. One of the companies is actually based here in Seattle. Who's heard of Carbon Robotics here? A couple of people. Amazing company using broad-scale ag, using AI and lasers to identify weeds and then send high pulses of laser to take out weeds without tillage or glyphosate. So there's a lot of interesting technology emerging. And that's going to come very quickly into the wine industry to solve real problems. So these 6 big buckets that personally I see is around water management, which is critical from a sustainability perspective, diseases, pests, using some of the products that we've used for the last 50 years to control weeds, pests, and disease is not going to suit us for the future of wine growing. So how does technology help us get around that and provide solutions? Labor shortages, we all face this. Massive problems with labor. How can automation, robotics help us here? Soil health, tractors, sprayers, these heavy units going across compacting our soils. The move to lightweight robotic-based systems that are electric are going to help us here. Data. There's a lot of data companies coming out using sensors and data to congregate information to help us make better decisions. Yield estimates, missing vines, leaf roll virus detection, red blotch detection, broken irrigation line detection, gopher hole detection, to be able to capture all this information as you're going through a vineyard to help make informed decisions, or with GPS reference back to your phone, makes vineyard management so much more easier and more efficient. And then traceability, the introduction of blockchain for traceability right from vineyard all the way to the bottle. This is super niche, but really, really interesting space. So a couple of slides here just painting the picture of what this landscape looks like for current ag tech. There's some pretty advanced soil moisture systems, smart valve systems like the team at Lumo, contributing to significant water savings. So from a sustainability perspective, it'd be really hard to do this without some of the tech that's coming available. Weather and microclimates in terms of monitoring, predicting diseases, infection periods before symptoms even appear, is allowing us to better target our spray applications. So really incredible technology already in place and coming. NDVI drone-based mapping, so moving away from aerial-based mapping to drone-based mapping to also robotic-based mapping to get side views of canopies, so we can zonal manage based on a vine level. And this is eventually where this goes. Management, instead of being, originally it was vineyard, then it was block. Soon it's going to be vine-based management. Decisions made specifically, how much nutrition does your vine need? How much sulfur does your vine actually need? Decisions based at a vine level. And then this early disease warning technology that's available as well, spore trap, identification and mapping as well. Another big opportunity for the wine industry that's already here. And then robotics, drones, biotech, AI. This is another huge shift that's coming in the wine industry. And the technology's there, it's emerging, and there's commercial players already in play. Autonomous robots, and we'll talk a little bit about that shortly in terms of some actual examples. AI predictive modeling, the biotech, there's a lot of investment going into biofungicides, for example, to provide softer solutions for chemistry and for powdery, downy botrytis control. And then precision application, vine-based precision, based on what the vine actually needs and based on what the soil is actually showing. And as you can see on the right, some pretty significant benefits that this technology can provide, that without it, we wouldn't be able to have this type of impact. So these are some really strong quantifiable wins that AgTech can help enable and help accelerate from a sustainability perspective. So water use, we can comfortably save 30%, 20 to 30% based on irrigation monitoring, evapotranspiration measurements, soil-based measurements, fungicide applications, targeting with better models, spore trap monitoring. We'll talk about this shortly, the use of UVC, herbicide inputs, the move away from herbicides. There's some exciting technology in this space with robotic lasers, undefined tools, precision sprayers to reduce the amount of herbicide being applied, AI-based sensors to detect what's a weed, what's not a weed, so only a small amount of herbicide is delivered to that actual weed. A lot of excitement around this space, particularly around the laser area, which I'm particularly excited about from a robotics perspective. Big increases in beneficial insects with the likes of using drones to release beneficial insects, super efficient way to do this. Organic matter increases. At O'Neill, we were using the agrology soil-based sensors to really quantify real-time organic matter, soil organic carbon improvements, and be able to see that in a side-by-side context. And then spray timing accuracy, a huge opportunity that AgTech enables. So I'll just give you a couple of examples here of what we're doing in regards to innovation at Saga Robotics. So this is our Thorvald robot, Thorvald in Norway, which is where our company was founded. It means God of Lightning, symbolizing strength, power, protection. These are autonomous, battery-powered, lightweight robots. These are about 750 pounds, using UVC to control powdery, downy botrytis and sour rot and wine growing. And the way these work, just a quick little clip here. So they basically are all RTK GPS referenced, operate at night, applying UVC to control powdery, downy botrytis, sour rot. This year, Saga will treat about 30% of the strawberry market in the UK and about 3,000 acres this year in California vineyards, making Saga Robotics now one of the largest agricultural robotics companies in the world. But what's driving this is these three big buckets: chemical-free disease control, labor-light operations. One person can oversee 10 robots. What's interesting about that is when you meet the teams out in the fields, like I started my career when I finished university as a as a machinery operator, Vineyard hand. And so I remember mixing chemicals, and no one likes doing it. Even still, you meet the Vineyard operators, no one likes spraying. And when you tell them, the teams, that they get an opportunity to be robotics operators, like we still need people to oversee the robots. They can't just go random and go rogue by themselves. I mean, they can, the technology's there, but by Cal-OSHA law, we've got to have someone overseeing the robots. So one person can oversee 10. And you should see the excitement on people's faces when they, all of a sudden, that being told they're going to be a robotics operator and they're not going to need to spray these chemicals anymore. They're always excited. And then really tangible carbon reduction benefits, lightweight robots, battery operated, no diesel, no runoff, no re-entry period. None of these products are on the vines. So it's moving from this blunt, harmful approach with chemicals. I saw this firsthand. My father was a tractor driver operator. He unfortunately passed away of overexposure to chemicals. So my personal mission in life has been to how do we remove as much of this from agriculture as possible, and this is a great option. And then some case studies from growers across California. Big reductions in chemicals, reduction in number of spray passes, and big increases in areas being farmed this way now. So just before we head over to our panelists here, where to start from an ag tech perspective when you're framing up and evaluating your technology needs? My advice and recommendation would be identify what is your biggest problem that you face as a grower. What's your number one problem that you'd like to solve? And then measure where you currently are, define what successful metrics and what success would look like, assess whatever the company that you're looking to work with, assess the grower case studies that they have, talk to the growers that they've been working with, and then pilot first. Start with blocks, a certain vineyard, test, and then integrate, verify, and then amplify through scale once comfortable. And so I put together this before you buy, like, questionnaire evaluation checklist. What is the problem fit? What does it solve? Pilot first. Look at the ROI timeline. Talk to those reference sites about their experience. Data readiness in terms of getting that baseline information. Does it integrate with your current systems, or is this a silo system? Just something to be aware of. And then operator readiness as well. Sometimes I think we don't think about that change, and going from tractor-based machinery to robotics is a big shift. Going from chemical farming to UVC farming is a huge shift. So you've got to be really mindful of that. And from the labor perspective, staffing perspective, sometimes they're really concerned with the move to robotics and autonomy, that these robots, machines are going to replace them and that they're not going to have jobs. So you've got to be out in front of that and talk about, no, we need people to oversee these. We want to upskill you and want you to be a critical part of this future of farming. When that changes, everything changes. If you don't have that conversation, then the opposite happens, and people don't want the robots or the autonomy to work. And then what is the sustainability fit? How does this enhance your sustainability goals? So yeah, technology is this, in my opinion, this sustainability multiplier that can really accelerate the speed and the of how much change we can do right from a sustainability and regeneration perspective. So there's enough from me. I'm going to let the team here introduce themselves before Matt kicks us off with his experiences. But firstly, Matt, tell us a little bit about yourself, who you are, whereabouts you're from, and
so we're not there yet. We're not into the robotic stage yet. We are purely a grower, but Matt Doyle from the Finger Lakes, upstate New York. We are a 500-acre I guess, multi-variety farm. We grow 35 varieties, so I feel a little guilty after hearing some of the places last night can grow 10. But we kind of do, I kind of say we have two businesses. We have the bulk business still, and then we have the high-end vinifera business. And it's, for us, it's kind of a diversity for us to stay strong and make sure we, have places for all our grapes to go. But it's been kind of a thing for us. But I'm happy to be here. It's the last couple of days being in Washington. I've never been out here before, so it's been really neat to see how it's done out here. So I'm thankful for that opportunity to be out here and see that. And I'm also thankful to be a dry farmer. I never realized how lucky I was to be a dry farmer. And we try everything we can do to get rid of water. So we spend thousands of dollars in underground drainage to get rid of water. So it's kind of, I joke about it, but it is amazing to hear how much of a struggle water is when, Dave and I, it's like right now we've had 4 inches of water in the last 2 or 3 weeks, so we can't even get into the vineyards. It's so wet. So it's interesting to see the differences across the country. So yeah, we're happy to be here, and let's roll.
Perfect. Cade Casciato, I manage Ciel du Cheval Vineyards, Red Mountain AVA, just down the road. We're about an hour away from here. We're a 140-acre farm, 120 acres planted, 16 different varieties. I do all the vineyard management and viticulture work and all the day-to-day operations there.
Greetings. My name is David Markel. I'm with Willamette Valley Vineyards, and I am the research and development manager. And sometimes I have a hard time with people wondering what that is. I span from the vineyard all the way through the tasting room, national sales. But I would like to say that I align with Ryan from the Climate Action. You don't have to be a sustainability expert. That's me. I come from 25 years at HP. I was in engineering and computational modeling. So I have a strong background in innovation. And I also would like to say that I'm the Climate Action panel because I bring a different perspective. So thank you.
All right, thank you guys. And I would like to pass over to Matt here to go through his presentation about how he's incorporating and how he thinks about technology in his context.
Yes, we're highly mechanized. We machine harvest. We have multi-row sprayers. We do all of our post pounding. Which post pounding, I don't hear much talk about trellis here, but you end up using a lot of wood posts back where we are because the soil is real acidic, so it doesn't like metal post. So we end up using a lot of wooden posts. We break a lot of them with higher yields. So we have gone to a 4-row post pounder. So there's different things like that we've tried to do to help us be more efficient. Let's see. We are also into the cover crop. We're heavily into putting cover crops in now to help soak up more water and just be a little bit more on the sustainability side of that stuff. And then we are heavily into data management. So we use an ag code software to manage all of our payroll and systems and help us to understand what our costs are. So I set these slides up a little bit backwards, but I'll do the best I can. But there's a picture at the end that'll show all of them. But in our for our field operation, I just picked out 4 different things we do. I already kind of talked about them, but we use 3-row multi-row sprayers, and we used to use 4-row sprayers. We kind of got away from those because they were awfully hard on the harvesters. The spray materials are generally acidic, and we found that they were hurting our harvesters over time. So we went back to a 3-row sprayer, but still, for us, it's more timely, but it's a lot less people spraying. We can spray a lot quicker, so we can spray less days per week. I think we have 3 of these now, so we can get our sprays done in 2 days versus 5 days, and it just keeps people out of the sprayers that much longer. We keep our newest, most best tractors on those sprayers, so the operators are a little more protected. And then on the Bobcat side, we just have a 4-row sprayer or 4-row post pounder, which helps us a lot because it's instead of doing 1-row post pounding. We're able to cover 4 rows, and it eliminates a lot of extra passes through the vineyard. So, and the cover cropping, as I said, we're trying to do that on almost all of our vineyards where we can. It's a time-consuming issue for us, but we are working away at it. And then we have maintenance tracking to track all of our equipment repairs to make sure we are keeping them up to par. Okay. This is just a picture of what I was talking about. So the bottom left-hand corner is the 3-row sprayer. We have a few of those. On the bottom right-hand corner is and I'm sure you all know what these all are, but this is our summer hedger with a mower on the back. So we're trying to do multiple things during one pass. Sometimes we'll incorporate we try to put as much stuff on the tractors for each pass when we go through as possible, just to maximize the usage of that pass through. And as I told you, we've had 4 inches of rain in a month, so we've had to really be like, well, we really can't get into the vineyards right now. When we can, though, we try to make sure we're not compacting the soil, because that can be a real issue for us. We do have some clay type soils on a lot of our farms. So you can imagine if we're compacting that over time, it's like concrete when it does start to dry out. So in the top right-hand corner is our cover crop machine. So we've been using that as much as we can. And we have a crimper that goes through, sometime a month later or 2 months later, depending on what we put in, to crimp that stuff down. And then the top picture on the top left is the post pounder I was talking about. So where we spent a lot of time recently is ag code, and we've been in this system for 10 years. It helps us track all of our costs, which seems kind of simplistic, but it's really helped us to understand what our costs are, because we are, as it is across the country, we're very pinched on margins right now. So we're trying to figure out how do we stay in business? What is the best way for us to make sure on all of right as we grow that we can, be around for the future, and make sure, because I have 4 kids, 2 or 3 of them want to come back on the farm. How do I preserve it for them to come back? So we're trying to make smart decisions. It also helps us to stay, up to all of our people we sell grapes to require us to have pesticide records. So this is an easy way to track those. It's a great way for us to try to look through the end of the year to see where our hidden blind spots are. And then it's also, this is where we're starting to use AI, is on the financial side of it. Also, so we're trying to set up SOPs for everything we do, whether it's a foliar sprayer operator or even our HR person. Where are the SOPs we can have in place so that if that person was to be sick for a long time, then someone else can come right in and do that job right away. And that's where AI has helped us a lot so far. I don't see it on the vineyard side yet. We're a little bit away from that, but we see it where it's going to be useful for us on creating spray programs and that kind of stuff. So yeah, we are trying to make sure we are in the Finger Lakes region is a beautiful natural freshwater lakes. There's, I think, a chain of 11 lakes that are, they're all very beautiful and pretty. So the idea for all of us is to protect those. Water quality, as our neighbors want to make sure we're doing everything we can to make sure those lakes stay clean. And we, obviously we all live in those neighborhoods and villages too. So we want to make sure the lakes are also kept well. So we're trying to do our best to make sure we have, we use soil and water to help us with setting up diversion ditches and all these things to prevent water from going in the lake or dirty water going in the lake. So it's a process for us. So that's how we are working towards being sustainable.
Great. Awesome. Great examples. Thank you for sharing. All right. Over to you, Kade. And you're welcome to stand up here and click yourself, or I can click for you. Whatever.
It's okay.
Yeah, you're
no,
good? Okay.
that works great, Caine. You're
Okay,
doing
great.
a great job,
All right.
man. I appreciate it.
I feel like I'm adding value, yes.
No, it's great. So I'll give you a little bit. My intro was very short and sweet, so I'm going to give you a little bit more background. Ciel du Cheval was initially planted in 1975. That's our oldest block. Our current planting went in about 4 weeks ago. So we run the gamut from 1975 to 2026 now. Initially set up as really a research and teaching vineyard, really big priority on research teaching. So we run a lot of our own R&D, and we try to cooperate with as many projects as we can with the universities. So we work very closely with Washington State University, Oregon State University. We've got projects with UC Davis, and then we do a lot of beta testing for new and emerging companies all around the world. So we worked with people from Israel, a lot of companies out of California. And so that is really kind of our big focus. The nice thing is, we're really set up to collect a lot of data, use that data to make faster decisions, better decisions, more accurate decisions, and help us both on general operating, crew movement, and timing of those types of things. Go ahead. So across the vineyard, we're set up with 54 individual blocks. We have a fully integrated telemetry mesh network. So we are collecting data 24 hours a day, 7 days a week on soil moisture. 54 blocks. I've got 80 soil moisture probes in the ground right now. So that's a tremendous amount of data that we're able to collect. We've got meteorological stations. We can do, soil temperature, soil moisture. You can read it. Ambient temperature, berry temperature. We actually have some really cool little sensors that we can embed in berries, and we can track the ambient temperature, the canopy temperature, and the berry temperature. Red Mountain's really hot. It's very, very hot out there. The wind blows crazy. And so knowing and understanding growth and development phases and the different phenological phases in these harsh environments is absolutely key, especially as we see transitions in weather patterns. So we all deal with heat. We all deal with those types of things. But when we're looking at a tremendous amount of heat spikes, heat domes, those things seem to be coming in at different times, different intensities, different durations. And so we're trying to learn as much about those types of things and the growth and the stress on vines and how that relates to quality. How can we be adaptable and relate that back to wine quality? So a couple of the current projects right now, if you go ahead. We do a lot of irrigation work. We've got 8 machine learning models right now that are targeting very specific stress levels in plants. That's been in operation for almost 8 years now. We did several years of building the models, proofing this out in the vineyard, and then running these things. But it's more than just looking at filling up the water level, looking at depletion. There's a lot of information that can be learned when we're collecting this type of data. And so this just kind of highlights some of this. And the dry farming one was really interesting too, because we actually do notice, if you look on the bottom right of this, we do get nighttime replenishing. So we're not exactly sure what that is. Our assumption is it's probably capillary action that is bringing that water back. But we actually do get quite a bit of replenishing during the nighttime when we have no evaporation and no evapotranspiration happening as well. So, taking these insights, collecting this data also helps us set up for the future. We're not starting, as new technologies come online, we're not having to start all over. We've got a massive data bank that we can go back and just start feeding this information as we start developing more models. So this has been a huge windfall for us. Another thing that we're working on right now is heat mitigation. It gets really hot out there. On the top middle, you'll see the bright blue, bluish purple block, and then kind of upper left, you'll see another one. This was a 105-degree day. We have been working on heat suppression so we can drop that delta T and protect fruit. That the little block up top is a block of Nebbiolo, very sun sensitive. Until we installed the heat suppression, we would lose typically about 50% of that crop. And this is the most expensive block to farm on our place. So the cost savings was just, it was a no-brainer to get this done, make this happen. And then on the other one is a high dollar block of Cabernet. So the average bottle price starting on that block of Cabernet starts at about $180 and goes up. So it's well worth it to protect those types of investments. So, and then another project that we're working on right now, this is a little FLIR camera that hooks to an iPhone. And unfortunately, I'm the guy that has to do it and go out at 105 degrees and take pictures. This is all infrared pictures, and this information is coupled with our ambient temperature, with our canopy temperature, and with our berry temperature sensors. And then all of this goes to the cloud over to WSU Precision Agriculture. And this is a model development that will be found on AgWeatherNet and Decision Aid Systems for predicting sunburn risk for Washington fruit. And then we have, we're pretty fortunate to be in an area where we've got a lot of engineers and a lot of retired engineers, and a couple of them like to come hang out at the barn. And we had one gentleman that just wouldn't leave, so I put him to work. And we've been working on some image recognition where we can actually go out in the vineyard right as cluster inflorescence are coming out. We can image those clusters, and we're getting ideas of, fruit yield, basically right now. So we're not having to wait. We're getting that information in some cases many months ahead of time, and so that is a radical thing to have on your side when we're talking about viticulture work in prescribing and logistics and moving people around and the timing of those types of things. So these are not perfect. This has been we started off with many failures. This is not perfected. This is not fully operational yet, but it's the proof that with a little bit of money, a little bit of investment, a little bit of time, going out, talking to people, partnering with people, you can do these things. You can absolutely do these things. So, this is a four-wheeler. This is my old intern, Jesse. Jesse actually just defended his master's thesis last week, I think it was. So he passed. So good for him. Generator on the back, couple computer monitors, and a camera, and a couple 2x4s and a piece of plywood. Yeah, there you go. The other thing that we've been doing over the last 10 years, we've been, unfortunately, we've basically on Red Mountain, it's a very small area. Everything is completely contained. We are not spread out, and so we are almost a true monoculture out there. We've done that to ourselves, but we've lost a lot of the native plants and that original structure that was there before us. So over the last 10 years, we've gone in, we have worked with several native plant nurseries in the area to get plugs to plant. We have so many native plants on the property now that we can actually harvest seed, we can transplant. So we've been working on any open space that is available. We go back into native plant reclamation, get those plants back in there. We've seen a tremendous amount. It's kind of one of those things where if you build it, they will come. So we've got parasitic wasps coming in. We've got bees and butterflies and things that we wouldn't have seen, 5-10 years ago are making their way to our area. So right now, we're a little over 30,000 native plants planted back to the property.
All right, I'm up. I'm going to talk about our small plot UVC trials and what we learned to use UVC to control powdery mildew. Next slide, please. In 2021, we learned about research showing that UVC could suppress powdery mildew, and so we purchased a fully autonomous UVC platform, and that's it there. It came crated up. We put it together, and with the assistance of Walton Haffey and Alex Wong, we got the robot up and running. However, autonomy is not, right now for Oregon vineyards, we learned it's more for a controlled environment. So we didn't give up on the technology, we just needed something different. Next slide, please. So cost is, since Willamette Valley Vineyards isn't looking to be in the business of UV light control, but Jim Bruneau is very passionate about sustainability, and so how could I get creative and continue on with this project that we believed in? So I took a collaborative approach, put together a group of academia and industry, and hired some engineering students, put together a project with George Fox University. And I think that talks to helping create sustainable people and creating what I heard earlier about future leaders. I would like to say future sustainable problem solvers. And so the engineering students came up with a design and build for our new UVC platform. Now the constraints were that it must fit a standard tractor, 3-point hitch and PTO, And you'll see there that it has an over canopy design, which was a little complex, so we simplified it. So you just hook it up to the back of a tractor and you just pull it like a sprayer. Next slide, please. So what we learned is that we trialed this in 2025 last year at our Brno Estate vineyard. It's our biodynamic vineyard. And we found that UVC matched our spray program through early June. We had about a 5-week spray-free window. And so that was somewhere between 2 to 4 fungicide applications that we were able to reduce. And that's during pre-bloom to bloom period. And so my understanding, that's an important time. Again, I'm not a viticulturist, but spore data, we took spore data showed suppression through mid-June. However, we did get a clear spike in late June as the canopy growth increased disease pressure. And so I slowed the tractor down. This was all work I did. I sat in a cubicle for 25 years, and then I'm in a tractor. So if I can do it, anybody could do it. So I slowed the tractor down to increase UV exposure. However, it still didn't help. Our findings supported the research that canopy density prohibits the light getting in to effectively treat powdery mildew. So again, we're not going to give up because every great story has failures and triumphs. So this year, I've taken it. You'll notice that we're using the Monarch tractor, and we had the PTO. And one of the problems was, as I'd get around the corner to slow down, the RPMs would reduce, the lights would go down. So this year, we're wired in, so it's electric, just like the Saga robot. So we're just running off the Monarch battery, and so I can just turn it on and it'll be powered. And we're going to look at increased frequency. This test was only one spray every week when I did the treatment, and it was once a week. And so we'll look at, I've moved it to Willamette, to our main estate in Turner. I live closer, so the commute to run the spray program, I can increase the frequency. And we're gonna look at how can we improve getting into the canopy with maybe fans, or I'm working with Walt. So this isn't just me doing this. I work with Walt Mahaffey and his guidance. And so the next are 2 videos. It'll show early season. Well, you see the canopy. And then the video after this shows it in operation when the canopy is denser. And you'll notice the speed difference in the tractor. This is about 2.5 miles an hour. And so the next one, I went down to 1 mile an hour. Now you're probably thinking, that's too slow. I can't. This is proving the technology. It's a combination with spray. Obviously, this is a tool, but you can go to the next one, please. And so that's, there's definitely a lot slower, but a denser canopy.
Is that light enough to pull by an ATV?
Well, the students in engineering, they say, when in doubt, build it stout with something you know about. So we definitely, and that's why when we had the overhang, I was not comfortable, because it was we were going to have over the road, because that's the way the Thorvald and Oregon State's Dragon are, but it just was not. I was not comfortable driving his tape. So it's bulletproof. So we can make it. We can definitely improve it with making it lighter. There's definite improvements there. And one last challenge is measuring the dosage that we're getting. That's very challenging. I had dosimeter dots, and they just do not respond fast enough. So there's definitely a lot of improvements, but we're not going to give up. And I think it is definitely something that's exciting. Next slide.
I think you'll see pretty significant improvements when you go to twice a week applications as well as putting fans on to help penetrate the leaves a bit as well.
So there's one last slide. So I just want to thank everyone, Saga Robotics, for actually it was convincing them to sell us the first robot. So anyways, that's all.
Awesome. Thank you so much, everyone. So we've got a few questions to ask the panel here before we all wrap up and drink some wine together. But to start with, for everyone here, I should have had a drone bring in these questions to be a little bit more innovative than reading off a piece of paper here. But what technologies do you think offer the most accessible entry point into ag tech that offers the strongest return on investment?
We've got. I think you mentioned a little bit about variable rate spreaders. Most people where we are put some sort of fertilizer on. We have, like I said, low pH soils generally, so we end up having to put a lot of lime on. But the spreaders with the variable rate can really help us to cut down costs because we can actually put the lime where it needs to be. So we may have an area in the vineyard where it needs 3 tons an acre. We may have an area that needs none. So that's really helped us. But since we're already spreading lime anyway, if we just put the stuff on there to help us put it on where it's supposed to be, it's a pretty cheap investment for us.
Yeah, I think for us and understanding the basics of viticulture, it's soil moisture monitoring, I think is probably the largest bang for the buck in just the ability and the information that you can really glean from that and get to understand how those vineyards are. And when we think of, and we're in an area as well that, there's a lot of nitrate pollutions in the soil. And so if we're using chemical, if we're using fertigation, we are not overshooting anything. We are not leaching anything. We can account for every single drop of water that hits that soil, and we can track to the exact level that those things need to go to and no further. So I think, from a cost standpoint and the efficacy of these products, we can really kind of hone in and dial in those types of programs, and then we just gain a whole other host of information. So I think, soil moisture and that monitoring for us is just lights out, unbelievable.
I would say weather stations. When I first got to Willamette, we didn't have weather stations in our vineyards that were spread out throughout the Willamette Valley. So I installed weather stations, and so now I'm plugged into the weather stations. And since 2022, I've been collecting the data and plotting our growing degree days. And so I'll send out that information. One of the interesting things I've noticed, our winemaker said, during a meeting that we have, it's a little earlier. So I plotted this year's growing degree days compared to the our last couple of years that we have data, and we're already probably, since March had a almost 40 heat unit influence. We're shifted. There's a definite increase where we're at in heat units already. And so I send that information out so that the winemakers can act on it. But I never hear back, except for one winemaker saying that, looks like my August trip is canceled. So But that is, I think, an easy way to, because we're spread out throughout the Willamette Valley, and I think it gives our winery ambassadors, I'll share that information with them so that they can talk to our guests about how the grapes are growing, educate them. So if we can bring the technology, because are these individuals, well, maybe Matt is, but in the tasting room, there's a lot of passion. How do you get that information into the tasting room? You know, and so I think that's an important an opportunity.
Yeah, really, really good point. So we've got about 8 minutes left. Questions from the floor. We've got plenty of questions here to keep asking the panel, but I think it'd be great if there was any questions that anyone had about ag tech, technology as a whole, opportunities to integrate into their own operations. Any questions, anyone? Yes.
This is a question for Kade, my friend, so I can ask you the hard balls. How do you manage data overload and being able to make an actionable decision from all that data?
Yeah, I definitely think bandwidth can be a problem, right? I'm one guy working on these projects. For me, you don't do these things by yourself. You go find people, you find help, you work on them when you have time to work on them. These are not necessarily overnight things. These are complex problems that we're looking at, or I don't necessarily think they're complex problems. What I think they are is I've got intellectual curiosities about things, and we need to find answers to those to satisfy me. So that's where the complexity lies. But yeah, they do take time. Don't bite off more than you can chew, and use resources. We're really fortunate that WSU is in our backyard, and we can call up the Dr. Kellers, we can call up the Michelle Moyers, we can call up you, and we use those resources around us. I've got a cousin that works for HP, and he's in development, so I'll call him and put him to work on a small project, you know, and so I utilize resources around me as much as possible to take weight off of that, because the rest of my job, I'm still having to manage the vineyards, managing the crews, managing, you know, every other aspect of that farm. So I kind of take a look at these things like I do in viticulture. Nothing gets solved in 1 year, right? These are multiple year projects. So slow and easy wins the race.
Are you using a specific platform or software to manage all this data?
We've built a lot of our own. And then I think one of our questions was about limitations on these things. Some of the limitations for me, especially in a contraction like this, and you know everybody wants to preserve capital, is I want to go with systems that I don't have to pay a subscription for, right? I don't need to be paying $7,000 to $10,000 a year to access my own information. We are very fortunate at WSU, and I'm right in the middle of changing all my stuff over from to LoRaWAN, which I can host on my own private network from WSU. They are the host site, and so they become my new dashboard at zero cost to me.
Nothing commercial.
Yeah, there's all sorts of commercial stuff out there. So typically on the soil moisture meteorological stations, those types of things, if you want to pay a subscription. The other part of that is if you're going to buy something, it needs to be really robust. I mean, it has got to hold up. Ranch Systems out of Novato, California is probably the best on the market for those types of things. Valve control, again, that's Twig, Nelson Irrigation out of Walla Walla. No subscription, and I can, you know, be on a mountaintop or on the river fishing, and I can pull out my phone and run my irrigation schedules. So that's another no cost one too. So there is some, you know, input cost, setup cost for, you know, revalving, and those are all 12 volt DC latching solenoid type systems. Just little pulses, and you're up and running, but pretty minimal investment to get going.
You chose to go ahead and measure soil moisture status as opposed to vine moisture stress. Why is that?
Well, we've done everything. We've got many plant embedded sensors, the flora pulses, sap flow. We've got them all. We've got data on all of them for us, and looking at data and the accuracy of that data. Volumetric water content through a capacitance-based probe just gives us better data. When we're working on research, it's a little difficult because there's not a direct correlation between volumetric water content and say like soil tension. So we've got a lot of these models we've had to, field proof and bridge those gaps to get these models put together. But yeah, absolutely.
You didn't mention pressure chamber.
That's all of our models we had to field proof with pressure bombs. So we didn't do pre-dawn. So we did stem water potentials, and we did hundreds of them a week for years to get that done.
Midday's fine. There's currently coastal vit consultants are doing infrared thermometers for vines. Have you tried that?
We've tried other things, so leaf pyrometers and our heat suppression is also set up on. We've got thermal couplers out there, so if we hit 103 degrees, it'll automatically kick on. We've got leaf wetness sensors, so as soon as they get wet, they'll shut down. We've tried almost every technology out there, but again, bandwidth. I can only manage so many projects and so many things, and so if we're looking at a project for the farm. It really needs to help us out in the efficiency way. We need to be able to scale that very, very well, and it cannot take away from our net profitability either.
One more question there down the back. Hi.
Yeah, hi. And Kate, and to anyone in the panel, this is kind of you building on our conversation last night. So if you have all of this data, it does create a little bit of an infrastructure investment. But are you seeing a potential monetization payback on the other side as it relates to risk mitigation for insurance or capitalization requests?
There's definitely a benefit there for sure. I think some of those come in ways, and understanding how the vineyard is set up really from a research and teaching aspect is some of these are requirements. Like this is what the owners and this is what the board of directors demand of the vineyard and demand of us. But that makes us really think about what we're doing, why we're doing it, and those investments, and really understanding what those ROIs would be, and then what benefit is it going to provide us? Is that better logistics? Is that a cost savings? Is that there's a whole host of things that we can look at, and although we're not necessarily trying to monetize that, I think if we were to package machine learning models and put those out to market, could we sell them? Probably, absolutely, without question, yeah. But I think doing that, there's a big gap. Like, it's expensive, right? To go outfit an entire vineyard with soil moisture sensors and those types of things. That capital cost for a vineyard to do that may not work out for most people. So we hold the data, we look at the data, we use that data for future development. But right now we're not packaging anything or trying to sell it.
But has an insurance company reduced the risk that they would? So I mean, brought down as a result of the valuation? No? Interesting.
All right. Well, we're going to wrap up here. Thank you, all panel members, for stimulating conversation. Thank you. It's a pleasure to be here. Really interesting space in terms of where ag tech is going and how it can help us advance both sustainable and regenerative wine growing for the future. So look forward to continuing the conversation over a glass of beautiful Washington wine here shortly. So thank you.